Hello, fellow psych students.
We are your hosts, Victoria Vanderheiden
and Caitlin Weber.
Do you want to hear a shocking fact?
Did you know that there are as many neurons in a human brain as stars in the Milky Way?
Shocking!
Anyway, if you didn't get it already, we're going to be talking to you all about neurons and neuronal transmission. So let's get started.
To understand neuron transmission, let's start with the basics. Victoria, take it away.
Alrighty, well, neurons are informational messengers. They communicate through both chemical signals and electric impulses. The electric impulses help the neuron communicate with itself, while the chemical signals transmit information to different parts of the brain and between the brain and the nervous system.
All neurons are made up of three basic parts: a cell body, an extension called an axon, and little dendrites over here.
So the white spikes.
Yes.
The dendrite fibers receive messages and conduct electric impulses. They are also branching extensions. An axon is an extension that passes through dendrite branches to other neurons and stuff.
Axons can be several feet long. Anyway, axons are very important. They even have this protective layer called a myelin sheath.
This white thing, the
Yeah.
white spiral thing. It's like a protective coating on.
Think of it like this. Dendrites listen, axons speak. Okay, tell me I'm wrong, but doesn't a neuron kind of look like a pom-pom?
No, it doesn't, Caitlin.
Dang it. Shoot.
No.
Right, it's my turn. Your nervous system controls everything you do, from your mind to your muscles, and even organ function. A cell body produces neurotransmitters.
Like this little green
The
thing.
axon terminal is where an electrical impulse is changed to a chemical signal. Neurotransmitters are in the axon terminal.
Neurotransmitters in the axon terminal. And the space in between neurons is called a synapse, right here. So there's a void right here. Signals travel across the synapse through neurotransmitters, chemicals that are recognized by the neuron and induce some kind of response, spreading the signal.
Neurotransmitters are released from one neuron to another. How interesting. Victoria, can you explain what stimuli are and what they do?
Yes, of course. So stimuli are senses or other neurons, which in turn cause neurons to transmit. Neurons communicate between the cell body and axon terminal using impulses, brief electrical charges that travel down axons. This is called action potential. It can be extremely fast, but even at its fastest, it is slower than electricity through wire.
Cool. So, the fluid outside the axon membrane has positive ions. Resting axon fluid has negative ions. The state is called resting potential, which polarizes the axon to a charge of -70. The axon surface is selectively permeable, like a cell membrane.
Or this Lego net. When a neuron fires, the axon opens a gate and positive sodium ions go through the membrane. So it's like having a hole in your Lego net. This depolarizes part of the axon, which makes another channel open, which activates a signal cascade or domino effect until the neuron is full of sodium ions. The sodium ions give the neuron a positive charge of 40.
After that, there is a resting pause called the refractory period, when the neuron moves the positive sodium ion back outside, which polarizes the neuron back to a charge of -70. Only then can it fire again.
After neurotransmitters move between neurons, what happens?
Well, some go back home to the original neuron in a process called reuptake. This is very important. Neurons have to reuse neurotransmitters over and over and over again because there's a limited amount of them.
Without reuptake, signals can't be transmitted because there aren't any neurotransmitters to send them. But reuptake doesn't happen to every transmitter.
Others diffuse or are broken down by enzymes through degradation.
So there are 3 different categories of messages. Excitatory neurotransmitters excite the neuron and cause it to fire off the message, meaning the message continues to be passed along to the next cell.
Pew! Inhibitory neurotransmitters block or prevent the chemical message from being passed along any farther. What's the last message type?
The last type is called modulatory, and these neurotransmitters influence the effects of other chemical messengers. They tweak or adjust how cells communicate at the synapse. They also affect a larger number of neurons at the same time.
Anyway, it says thing now. How interesting. That was a lot of information. Let's all stop and take a breath. Ready?
Caitlin, we have a time limit. We gotta keep it rolling.
Oh, right. So, this concludes our presentation about neuron and neuronal transmission. If you need to ask any questions, just watch the video again. It's probably in here.
She's joking. Ask us if you have any questions. We all hope you learned a lot, because you'll need it.
Wink, wink.
Have a good one, and thank you for watching.
This is take one. Number 14. Take 22. Inhibitory transmitter. No.